Astronomers have discovered a nearby asteroid that may have originated from the moon. Researchers at the University of Arizona are studying this so-called near-Earth object to learn more about, among other things, the early days of the solar system. Joining us now is one of those researchers, University of Arizona graduate student Daniel Castro. Daniel, thank you for joining us. Good to have you here. Near-Earth asteroid, possibly from the moon. How sure are you? Are there still questions? How do you know it's from the moon?
Okay, well, first of all, thank you very much for having me here and allowing us to share some of the work we are doing at the University of Arizona. We have still a lot of questions about this object and about um, all this family of objects. So it has been, this investigation has had several steps already that have led us to think that this object may actually come from the moon. So this object was discovered in 2016. Then in 2020, some astronomers here at the University of Arizona, they were able to measure what we call the spectrum of the object. So just to say it roughly, the way these objects reflect light, it tells things about the composition of these objects. And when they made the comparison with lunar samples, it seemed to be similar.
Interesting.
So now we have this hypothesis that it may come from the moon. So what we did in this most recent work was to test. Okay, so let's assume that sometime in the past, perhaps millions of years ago, there was some impact at the surface of the moon, and this ejected multiple particles away from the moon with multiple speeds in multiple directions. Is it possible that some of these fragments reach an orbit which is similar to this object? And what we have found is that, yes, it is possible. There is a small fraction of these objects that they actually reach an orbit like this.
Oh, and you mentioned orbit. I mean, this, correct me if I'm wrong, but it sounds like this is orbiting the sun, not necessarily the Earth. Is that true?
Yes, that is actually a very interesting point. So we call this object a quasi-satellite. So what is the difference with an actual satellite? So a quasi-satellite is outside of what we call the sphere of influence of the Earth. So inside the sphere of influence is where the gravitational force of the Earth is the most important. Outside of it, then it is mostly influenced by the sun. So this object is outside of the sphere of influence. So it actually is orbiting around the sun, but its orbit is very similar to the Earth. So it's very close to the Earth. Sometimes it is ahead of the Earth, sometimes it is behind. So from our point of view, it seems that it is moving around the Earth.
That is really fascinating. And you mentioned that, impact, things eject, and then, who knows what happens. I would imagine some of that stuff goes back into the moon, does it not? I mean, some of it goes down and some of it goes up. How does the difference? What makes the difference?
Yes, that is correct. So there are multiple factors that are going to be very important to determine what will be the fate of these fragments. Yes, some of them they won't be fast enough to escape from the moon. So yes, they are going to come back and fall into the moon. Some of them, they are going to go very fast and they will collide with the Earth. Or they can be also very fast and escape into a more heliocentric orbit, so closer to the sun. So there is a very delicate balance of all these different factors: the speed of the ejected particle, the direction, and also where in the moon the impact was produced. So all of these factors, all of those combinations, they produce a great diversity of possible fates.
Yeah, and again, correct. It would seem that if it's orbiting the sun, eventually it's going to be really far away and really difficult to see. Is that true, or can you just go ahead and study this, all year round?
So this object has the interesting property that we think its orbit is very stable. So So it is uncommon for this kind of near objects, um, but we think that this kind of motion, this kind of orbit is going to be persistent over even millions of years. That is what we think.
Wow.
So in this particular case, we think this is going to be a very long-term companion of the Earth.
Yeah, it kind of sticks close to home here, even though everyone's just circling the sun. Last question here, Daniel. This is really fascinating stuff. I know that people like to look at asteroids. You researchers like to look at asteroids to see what the Earth, what the solar system looked like when it was first formed, because everything's pristine and everything. Will this help in that discovery and in that research?
Absolutely. So if it is confirmed that this is an actual fragment of the moon, then it will be very important for multiple reasons. Because then a mission that is able to collect samples from this asteroid is going to be able to collect very ancient lunar material. So then we are going to get a very good idea of how the moon was millions of years ago, how has it changed from what we see now, and also just tell us that there are multiple origins for these objects.
Yeah. And last question, real quickly, Daniel, because we're running out of time. How big is this thing?
Well, moderately big. We think between 40 to 60 meters, and we think that its shape is very elongated, sort of like a football.
So a 40 to 60 meter football,
yes.
Then?
Correct.
All right,
yes.
Good enough to get a sample size. Daniel, great work. Thank you so much for sharing your information with us, and best of luck.
Thank you. It was my pleasure.